And next we have Tim Stevens, and his study subject is How Can Farmers Keep Nutrients Out of Water? Tim is sponsored by the Studley College Trust. He is a catchment advisor and agronomist working for Wessex Water. He works with farmers across Dorset and Wiltshire on ways of keeping nitrogen, phosphorus and pesticides out of drinking water. In his spare time, he plays rugby for Dorchester RFC and enjoys helping out on his family farm in Devon. His topic of how can farmers keep nutrients out of water, and he hopes that the findings of his Nuffield study will help the farming industry in its efforts to make food production more efficient and profitable, whilst at the same time keeping our water clean. Tim has already presented his Nuffield findings to several groups of farmers and advisors, DEFRA, the Environment Agency, and various other water companies. Tim.
Thank you for this opportunity to share the findings of my Nuffield study. I'd like to express my gratitude to the Studley College Trust and to the Nuffield Farming Scholarships Trust for selecting me and providing the support and funding that's made all of this possible. I'd also like to thank everyone who's helped and hosted me along my Nuffield travels. Thanks to my employer, Wessex Water, and also to my family for their encouragement. Without I wouldn't have achieved very much. My story starts on the red soils of mid-Devon, which is where I was brought up on my family's beef and sheep farm. But it's only as I've started to learn more about soils and agronomy that I've realised that when the water which runs off these fields is also coloured red, then something isn't quite right. The question I've set out to answer is, to achieve high yields of meat, grain and milk, do we have to just accept the loss of valuable soil and nutrients every time it rains? I've worked in the agriculture industry all my life. First of all on farms, and more recently as a catchment advisor and agronomist for Wessex Water. My brief is to work with farmers to keep nutrients in the field and out of water. Public water supplies like the one pictured. The alternative is to install expensive and energy-intensive treatment plants to remove nitrates and pesticides. Those are crop inputs that farmers have paid for. I think it's helpful to understand the scale of the problem of nitrogen and phosphorus enrichment of both fresh waters and marine water bodies. It's a global issue with an economic cost running into the billions, and it threatens many different habitats. The way we use fertilisers and manures on the average UK farm is still remarkably inefficient, despite several decades of big improvements. Nitrogen and phosphorus that isn't taken up by the crop can be lost to the atmosphere in the case of nitrogen, can enter watercourses, and in the case of phosphorus, it can accumulate in the soil over time. All this has led to numerous restrictions being imposed on how farmers manage manure, nutrients, and soil over the last 30 years or so. But further reductions in nutrient losses to water are still needed if we're to tackle environmental and drinking water issues. Yet at the same time, we've got this global need to increase food production, and domestically, we need to ensure food security through the uncertain times ahead of us. So to find out how to balance food production with this need for clean water, I spent 16 weeks visiting 10 different countries, all facing similar or greater water quality challenges to ourselves. Over the course of my travels, I've come to believe that there are three key principles that farmers can follow to maintain or even increase yields, reduce production costs, and reduce nitrogen and phosphorus losses to the environment. Firstly, if you want to manage it, well, you need to measure it. We've got a range of key performance indicators for measuring production efficiency in agriculture, but I think that the nitrogen and phosphorus surplus of each enterprise should be known by the farmer. The farmer can then decide what measures to take to reduce those losses. In the UK, we've got some of the tools and scientific evidence we need to be able to do that, but other countries like the Netherlands and New Zealand have given it greater priority. Secondly, we need to harness every available method of improving nutrient use efficiency of food production. There are many ways of doing this and new methods emerging all the time. Advances in plant and animal breeding, biostimulants, all sorts of different precision farming technology can all help us to grow more crop per drop. Technology can also help us to identify the poorest performing 5% or so of farmland, which we can manage differently, plant different species, to slow the flow of water through the landscape and with it nutrients in soil. But no matter how advanced the technology, it's the management skills of the farmer that ultimately decide the nutrient utilisation of a farm. The old saying, the difference between a good and bad farmer is about a week, holds true in this case. Timing is critical when applying fertilisers and manures. Finally, I think the solution to all of this is right in front of us, well, just below us actually. The one defining characteristic of all the farmers I visited who were doing great things for water quality was that they were actively managing their soil with the same degree of care and attention that they gave to their livestock and crops. If we can make sure that soil has enough pore space to hold air and water in equal quantities, enough microbes, earthworms, and organic matter, then the soil will hold on to the nutrients for us. Less inputs may then be required due to better nutrient cycling in the soil. Fertility improves, and the farm becomes more resilient to price and weather shocks. So we need to move away from an over-reliance on purchased inputs and build soil carbon instead. Farmers can't do this on their own, though. There are a number of other parties who can all play a role, of which I'll now give some examples. I liked the Iowa nutrient reduction strategies use of the 4 R's of nutrient stewardship and the way that they'd added some soil health messages to the overall elements of getting the right timing of fertiliser and manure, the right type of fertiliser and manure at the right time, at the right rate, and in the right place. The Iowa state government and even the fertiliser industry are all encouraging farmers to adopt a conservation agriculture approach whenever possible. Cover crops, reduced or even zero tillage, grass buffers are all promoted as vital measures for keeping nitrogen out of the Mississippi River. It has to be said, though, that the 4 R's are easier said than done. To get the right timing of manure application, the farmer needs enough slurry storage capacity to be able to apply that at the optimum time for plant growth, typically in the spring. That infrastructure costs, though, and the investment required is not usually rewarded by the markets that farmers sell into. That needs to change. Farmers in every country I visited faced restrictions on how they farm due to nutrient enrichment of water. The Danish government have spent over 30 years tightly controlling manure and fertiliser inputs. This has led to a halving in nitrate concentrations in groundwater without compromising overall agricultural production. But the investment that's been required to comply with those rules has led to very high levels of farm borrowing. In New Zealand, rather than restricting nutrient inputs and stocking rates directly, they've chosen to allow farmers to pretty much farm as intensively as they like, as long as they keep nutrient losses below a set limit. My conclusion is that both approaches have their merits and flaws. We do need a minimum level of regulation to prevent bad practice, but there are such wide differences in how well individual farms manage nutrients, manure and soil that I don't think the better run farms should be held back by the inefficiencies of others. Farmers need to be able to trust the water quality data that's used to persuade them to change their farming practices. I visited excellent catchment science projects in other countries, such as the Chagas Agricultural Catchment Programme in Ireland. The pictures of a water quality monitoring station in a mainly dairy farming catchment of County Cork, and it collects detailed water quality data that helps inform government and local farmers' decision-making with nutrient management. Water quality can take a long time to fix, so we need this sort of investment if we're to avoid making the wrong decisions that could delay progress by many years. A key element of my study was to look at how water companies can support farmers to reduce nutrient loss. But I also met with environmental organisations, NGOs and charities who are doing similar. I was struck by those that rather than criticising farmers, were instead funding them and supporting them to reduce nutrient loss. One example was the Sand County Foundation in Wisconsin, who had developed an innovative payment for performance scheme whereby farmers were paid for every kilo of phosphorus that they prevented entering Lake Michigan. If we're to achieve truly clean water bodies, though, we need to look beyond just farming. Water companies need to invest in advanced nutrient recovery technology to be able to recover the nutrients that we humans consume and excrete and reuse them as fertilizer in agriculture. In Delaware, I visited a good example of a wastewater treatment works that had improved its sewage treatment processes to be able to provide treated effluent to a local farmer to irrigate onto his crops. This is just an example of the many opportunities there are for farmers and water companies to work together to achieve a circular zero-waste economy. The technology for recovering the nutrients in animal manure also needs development in this country, so that farmers who've got a nitrogen and phosphorus surplus can recover the nutrients in animal manure and sell them as fertilizer to farms with a deficit. I came across an inspiring example of farmers joining together to take ownership of water quality issues and solutions when I visited a group of farmers called Peninsula Pride Farmers in Wisconsin. The picture shows the group leaders meeting with a local newspaper editor to communicate what they're doing to keep nitrates and E. coli out of local residents' private water supplies. Not only does this present a united front, but it also allows them to access public and private funding to implement some of the more costly nutrient management practices. The second point I want to make is that sustainable farming practices are just good business. The veg business in the picture switched to strip-till establishment of its broccoli rather than the more costly and traditional heavy cultivation method, which can lead to nitrate leaching and soil erosion. Consumer demand for food produced with less of an environmental footprint is growing all the time. So what's next for me post-Nuffield? Well, it's about continuing to work with farmers on the 3 key steps I've outlined and helping them to get rewarded for providing public goods like clean water. My final conclusion is that productive and profitable farming is compatible with clean water, but this will require a change of mindset and farm management in many cases. I don't think that the vast majority of farmers I know are managing their soils badly, but I do think that many of them underestimate just how much more their soil could do for them, how much better it could perform if they moved away from a system that's funded mostly by nitrogen inputs to one that's fueled by soil carbon instead. Only then, in the Downs and Vales of Wessex and in the mid-Devon Redlands, will the waters run clear. Thank you.